Hello. In this video, we'll continue our journey on object-oriented modeling. It's still part of our second learning objective in this week. Explain object-oriented modeling in BIM. So let's take a quick review of the Revit example for wall. If you look at the wall on the right side, this shows we have quite a few walls here, right? A few walls here. Now, all the walls belong to a class called the basic wall exterior. And apparently at the class level, we have a list of attributes and we have a list of methods or functions or behavior. Apparently under the same class, we can create as many exterior walls as possible. Of course, they will have different IDs, right? And the attributes may have the same value or might be different. You can also open the property window, look at the properties of the exterior wall. And this one lists all the attributes, that belong to the exterior wall, to the object that you just selected, as well as the values being popped in. With this one, you can also click this Edit Type button and it brings up another property window. In this place, you end up seeing a list of parameters, or they are still attributes, and the behavior, and the values, right? So it's a list of attributes with values here. So that's very interesting observation. As you can see that we have a list of attributes right here and have all the values specified for a specific object. On the other hand, we can open up the class window, right? And by clicking this Edit Type, and it gives us another list of attributes. We call them parameters, and also the values associated with them. The difference between these two sets of attributes is such: all the values here in this class, all the values here at the class level, they apply to all the objects that are of this type, For example, if you change the structure right here by clicking this editing window and bring up the structural editing tool and change the wall structure, the same change will be applied to all the wall objects, all the exterior walls that are of this type in your Revit project. That's the reason we call this a class level set of objects. On the other hand, if you come into this property window and make changes to the attributes, right? Make changes to the attribute values. The changes are only, or the values you set, only apply to this specific object. Other objects, even though they are of the same type, they belong to the same class, their values don't get changed there. So that's the difference. This one tells you that you have two sets of attributes. One set is at the class level, and then the other set is at the object level. This also reminds you, I think this is a good time to remind you that whenever your intention is to just make changes to the objects in your own Revit project, make sure you use this duplicate button. Otherwise, if you don't use this duplicate and give your type or class a new name, all the changes you apply here will be stored in the system. And in other Revit projects, when people have this type there, their attributes values will get changed as well. So be careful about that part. Now, this process goes to the same as for other types of objects. For example, looking at the windows, right? You can also display the window properties, and you can also invoke this Edit Type button to invoke the class level or type level attributes, make changes there. And again, make sure that you understand the difference of directly modifying the values versus using a duplicate to create a new type and then modifying all the values. All right, so we talk about your objects have attributes, and your attributes could be at the object level, could be at the class level, right? Now let's look at these two walls as an example. The left is a concrete wall. The right is a masonry wall. My question for you is that, do you have all the information you need in order to place or create the corresponding BIM model or in Revit? Right? Do you have adequate information to develop the corresponding models in BIM? I hope the answer is no. What we have just seen is just one set of the attributes that specifically refer to this shape representation. So as we mentioned, every object has a shape, right? Because in your BIM, in your building models, every object has a shape, has a geometry, has a location. So all the dimensions we just saw, they only represent the shape representation here. Apparently, this tells me that this shape representation is actually viewed as an aggregate type attribute. So in other words, you can have many more individual attributes organized under a single attribute, and this attribute correspondingly, we call that a complex attribute or an aggregate attribute, while others could be other types as well. So this example shows this is the lighting, right? This is the light class. And light class has a set of attributes, and some of the attributes are called, can be optional. So in other words, it's not mandatory for you to specify the values right there. You can leave them blank and make changes or fill them in later on. Now, this is what we talk about the shape representation. This is an aggregate. You have many individual attributes or properties in order to complete the shape representation. Some attributes could be derived. For example, look at the energy consumption. Energy consumption depends on the power or the watts of your light, as well as the time or the length your light is turned on. Some attribute may be a relationship to another object. For example, a light is typically controlled by a switch. So we can use a switch attribute to specify what is the corresponding controlling switch. So in other words, to say it again, an attribute may be optional, aggregate, derived, relationship to another object, or any combination of the above. When objects, as we say, we have objects, right? Objects have to talk to each other. They have to communicate with each other. So objects communicate to each other by sending messages. For example, viewing designer as an object, and the designer would like to calculate the area of an object called W1, or let's say this is our wall. This is our wall 1 right here. So the object designer sends a message to object W1 saying, well, go calculate your area. So calculate area is a behavior or function object W1 has. So object W1 does the calculation and gets the result and send this 1,000 square feet result back to the calling object, which is designer, right? So in other words, this process shows that objects communicate with each other by sending messages. And the process of sending messages is actually in the programming context, we call that an interface. So the reason we like object-oriented modeling so much is because of its primary characteristic of the encapsulation of data and the methods. So again, thinking about your objects, an object has a list of functions or behaviors and has a list of data or properties, right? So these properties and the behaviors, they all belong to this object. As such a way, because we call them belong to, you can envision that an object actually encapsulates all the data and the methods. This encapsulation has two merits. First, it increases the modularity and maintainability because you're talking about individual objects, right? So anything you change, you make modifications, you're always applying to that specific object. On the second merit is the simplicity of external interfaces, right? So this part, let me give you an example. When you drive a car, you're interacting with your vehicle through the interfaces, right? One interface is the brake pedal. So apparently you don't need to know how the car implements the braking mechanism in detail. All you needed to know is that if you put your foot on the brake pedal and push it hard, you expect the vehicle will be slowing down and eventually come to a complete stop, right? This is the braking. It's the braking mechanism. So similarly, when you try to accelerate, right? When you try to accelerate, you don't have to know all the details about how your car implements acceleration. All you need to do is to act on the acceleration interface, which is the gas pedal, right? So you push the gas pedal and your car accelerates. Does that make sense? Right? So this makes the interface a whole lot easier. Okay, so when we talk about objects and a class, we said that this is an instantiation and an abstraction process. So some similar way of thinking about this from objects to class and class to objects is more of a generalization and a specialization. When you pick the common parts and group them together, that's a generalization. When you take a single design and then put them into different subtypes, right, or individual objects, that's actually a specialization. So we can extend this concept further. For example, taking the wall as an example. When you look at the wall class, you can further separate or specialize wall into different types. Basic walls, curtain walls, structural walls, adobe walls, and the list can go on, right? And when you look at a specific external wall, for example, you can further specialize that down into external concrete wall, external masonry wall, and so on and so forth. So this process can continue on. So again, starting from the objects, right? We generalize, we abstract them together into group all the same type of objects into class. Now, concrete wall, masonry wall, and the brick wall, they are all walls, right? They are all walls. So the common point tells me that they can be further grouped together and give the name called wall, right? Called a wall. So this process is generalization. And the base classes, we call them subclass. And the parent class, we call it the superclass. All right, we call it the superclass. Now, similarly, we can go travel or navigate the other way around. You can navigate from your superclass to your subclass, and this is called a specialization. Now, this process, when we look at a generalization and a specialization, what we are saying here is that a subclass inherits every attribute and method from the superclass. So in other words, any methods, any attributes a wall class has, right? They all apply or they are all inherited by the concrete wall, by masonry wall, by brick wall. So this means that for that set of attributes and behavior or functions, you only need to define them at the wall class, at the superclass wall. And you don't have to replicate or redefine them in the concrete wall, masonry wall, and the brick wall. Okay, masonry wall. In addition to this common set of attributes and behavior, your subclass can have its unique set of attributes and behavior. So this gives you a lot of flexibility of defining something specialized, while also saves a lot of time and efforts by putting all the common things into a single location, into a single class. So thinking about this one, when we implement this in Revit, as you can see, we have a wall class, right? Wall as a class. Thinking about the wall class, you have methods and the properties. So let's look at the wall properties, just taking a list of wall properties into consideration. What you end up seeing is a keyword called inherited. Inherited from. Inherited from indicates that this is an attribute that belongs to this element class. And the reason this assembly instance ID is also showed here because your wall class is a subclass of your element class, right? This is the inheritance. the attribute gets inherited. And I also put a link to the document if you are interested in knowing all the details behind the scene. Now, the same thing, when you deal with the methods also goes the same approach. If you look at these methods, for example, taking this can be hidden method as an example, you end up seeing the same keyword called inherit, right? Inherited from element. So this again, this can be hidden method actually belongs to this element class. But you are seeing it here in your wall class, because your wall class is a subclass to your element class, and as a subclass, wall inherits all the methods from your from the parent class. So how do we implement that in Revit API? All right, in Revit API is such that if you look at this one, let's say you have your wall, and it's by default you have concrete wall, you have masonry wall, you have brick wall. They are all specialization, right? You can also create another specialization of your wall class. Let's say it's an Adobe wall. And by creating a specialized subclass of the wall and as Adobe wall, you can create many Adobe wall objects as you wanted to. So this is, again, this is specialization process can be continued. And all you needed to do is go use Revit API to define your own specialized wall class. And in order to do that, there are several different ways of doing it. And the easiest way is probably to go through the edit type and duplicate, right? And you can go to edit type and make a duplicate of existing class. And then you can add your specialized attributes or modified behavior, modified attributes. So this is the wall class. Again, you look at the wall type of properties. And in Revit, the hierarchy goes in such a way at the top level, we call that a category. So you end up with walls at the category level, and then you can further specialize them into basic wall, curtain wall, or stacked wall. I mean, they are all called a family. They are all called a family. And you can further specialize your family into individual types of wall, and they are called a type. They are called a type. And once you have the type, this is your base class. Okay, this is your base class. So let me see if I can write it. Base class. So this is the base class. And use your base class, you can create many instances or wall objects as you want to, right? As you want to. So look at the Revit model. These walls are objects, and they are abstracted together into a class called exterior brick on metal stud. And it's viewed as a type. And you can organize all the same types. I mean, the different types are viewed as a specialization of a basic wall family. And your basic wall, curtain wall, stack wall are three families that are viewed as a specializations of this walls category. So this formulates the hierarchy, right? So in this case, you end up with subclass, parent class, and this parent class or superclass becomes a subclass to this superclass category, So this is exactly what we are looking at, right? At the bottom, it's our instances or objects. And on top, this is our class, base class, right? Base class. And on top, we have superclasses, right? And on top we have superclasses. So in the wall case, it's this level is category, this level is family, this level is type. When you create a specialization, you can create a specialization at the family level. You can also create a specialization at the type level, right? At the type level. So the commonly used practice is always creating your specialization at the type level. For example, we can go edit the type and make a duplicate. Apparently, wall is not the root node, right? The root node. So this one shows in Industry Foundation class, which is an open standard object-oriented model. And no matter which BIM tool you use, such as Revit or other BIM software packages, they all implement this IFC structure. So in this IFC structure, as you can see, we have wall. Wall is a subclass to building element, and the building element is a subclass to element. Element is a subclass of product. Product is a subclass of object, and this object is a subclass of root. So this root is the root node to all the objects in a building model, right? In all the objects in building. So let's pause and reflect. Again, everything is an object, right? Every object has ID, values for attributes, properties, and the behavior methods. The same type of objects, we organize them together, go through a process called abstraction, and this abstraction leads to class. Class specifies attributes and implementation of behavior/methods. A class can inherit from other classes for specialization and subtyping, and this hierarchical inheritance and subtyping or specialization can have multiple layers. There's no limit on how many layers in the hierarchy you can have, right? So at this stage, we should have achieved the 2 milestones. First, we shall be able to clearly differentiate class and object. Second milestones, being able to navigate along the inheritance path, right? And figure out which attributes and behaviors can be carried from which class to which class. So here's our assignment. Assignment, inheritance in object-oriented modeling. I would like you to watch a YouTube video, right? And the purpose is to create a custom wall type in Revit and answer the following questions. How do we create a new wall type? How do we modify the structure of a wall? Describe how the inheritance concept is implemented in this process. So with this one, I would like to conclude this video.